Welcome to the Decode Podcast with Elias Malfovan, Daniel Stanfill, and Sean Kincaid.
Welcome to the Decode. We are on Rev 2, and our guest tonight is Jeremy Orbach. He hails from Illinois, has a BS in computer science. He is an application engineer at Omron Automation Americas. He's worked for Apple and Dell in the past. You might have heard of them. He is an automated inspection guru. So, really, without much more, I'll just go ahead and hand it over to you, Jeremy, because I know you've got a lot of data that you want to present to us, and you know the format that you want to show it to us in. So please, the floor is yours. Take it away.
Awesome. Well, I appreciate the opportunity to chat with you guys, and thanks for that introduction. So I actually just want to kick things off here with a discussion around quality, because we need to sort of paint a little picture here before I get into the data of how we kind of got to what we're going to be presenting today. And, I want to kind of have a discussion here with some experts in the fields about, their perspectives on quality, specifically you guys. So, everybody here is at least familiar with, SPI and AOI. We all understand that it's a quality control metric that we can use to different extents to generate value and prevent defects, right? So, with that said, I want to ask a question first, and that is, when you guys sort of think about AOI and SPI, what are the first things that come to mind, just when you're thinking about it?
Variance. How to catch defects.
Got to catch defects, agreed. Anything else?
Variance,
like it.
Sean, contribute.
I got nothing. I just want to say the answer because he said what it is. I got so excited, I just started smiling. Like, I know this one.
You know this one.
No, honestly, the first thing that comes to my head is a 2D AOI. I don't know why. I own 3D AOIs, but for some reason 2D comes to my head when I hear of AOI.
Sure. And how long have you been working with AOI, Sean?
2022, I believe 2022.
Okay, so that was your first 2D? That was your first experience?
No, 3D, always.
Okay, so when you think of 2D, it's interesting you say 2D. Why does 2D come to mind first?
I don't know.
Great question.
I feel like I'm in therapy right now. Maybe my childhood.
You have experience with 3D, but 2D is the first thing that comes to mind. And it's
that's a good point, because when I was doing PCB Fab, we had a 2D AOI. So maybe that's where it came from.
Back when you were actually building boards and you were doing some sort of quality control, you were looking at two-dimensional images to make decisions in the quality of the boards you were building. And that's sort of the basis of your experience and your understanding of both sort of AOI and SPI, correct?
Yeah, I would say the overall concept. It's tough to compare, though. The PCB one was trash compared to the one I use today. I'm not going to lie.
And that's totally understood. But that's one of the things I really want to get into here is, so, when it comes to AOI, it's been around for about 30 years. And, actually, Omron, the company I work for, invented the entire concept of AOI for internal purposes. And that was, back in 1987, we realized there was a need for quality control inspection around circuit boards. And we realized that need because we've been building products for industrial automation for over 90 years now. And when you're working, in the 80s to try and source circuit boards, you may have been getting just piles of boards that did not function. And as a result, you as the end, user of that had to return a good chunk of your product to the manufacturer just to say, hey, this doesn't work. So fast forward a little bit, we've got a bunch of people at our factories that are looking at the circuit boards that are coming in. They're covered in solder balls. There's parts all over the place. It just looks like, there's no quality control at all in place. So we internally decided at that point to develop a solution and try and figure out how we can start going about doing this quality control check. So, this is what kind of birthed the concept of quality control for circuit boards, especially when it comes to machine vision. So fast forward, 2D AOI, 3D AOI, we've been around doing this pretty much since the beginning. We invented it clearly. So it's interesting you said, once again, 2D is the first thing that comes to mind, because I think that's actually pretty reflective of pretty much the entire market at large. And there's a reason I want to say that, and that is specifically most customers approach it in sort of a 2D perspective. And what does that mean? Well, you can look at AOI data in just a very sort of granular fashion. You can look at it and say, all right, that's a defect. This is what my defect looks like. Cool. I caught my defect, kind of like you guys said. You can also see a whole bunch of what most people call false calls. This concept of invalid data that is just there to prevent you from being able to get what you need out of your machine. And this is the approach that's been taken for at least 10 years. I've been with Omron almost 6 years now, and it just seems like that's been the way it's been done since the very sort of beginning. So, when we're looking at AOI data in this 2D fashion, it's just simply a whole bunch of data that's filled with an occasional real defect and then a bunch of what we consider false calls. And, the whole concept of false calls themselves, which are the first things you guys brought up, is something that I've found to be something of what I'd call a misnomer. Now, what does that mean? That means that the concept of a false call is very misunderstood, because to what Elias said, variance is actually what we're looking at. And, I've been doing this quite some time. I learned this original system myself simply as a defect detection system. We sell this to catch all your defects so you know where to rework. But I also learned very quickly, there's a lot of data right here that I just tune straight out of the system, because that's what I'm taught to do. I'm taught to catch the defects. And all the rest of this data is just very difficult for me to tune. So I spent 2 or 3 years digging into that data itself and came to one singular conclusion at the end. And that was, I've been approaching this totally wrong. I've been tuning out all the data that actually was super valuable to me and to my process, just because I was trying to get it to catch defects and have few false calls. So, what I want to sort of just plant as a seed here is, when we're looking at this type of data, false calls do happen. And I want to own that false calls are a thing. Different companies, machines are going to produce different false call rates. But a false call in reality is the system just malfunctioning. And it doesn't frequently malfunction, Maybe on your old 2D AOI, Sean, it did malfunction a lot. Maybe it did just not correctly process the data.
Just way too sensitive. It would pick up any dust and like little debris and fail. And then you're just to get your golden sample, you must have clipped through, I don't know, like 400, false calls, I'll call them, just to get one. And then it was a nightmare.
Sure. Could you acknowledge, though, that the system was just over detecting insane amounts of variance, and there was really no easy way to get it to stop detecting as much variance as it was, correct?
Yeah, without employing like another process of like making sure you clean the panel completely of any type of dust, lint, debris.
Sure.
Every single process etched exactly the same, plated the same, hole was drilled the same, which is almost impossible.
Yeah, and that's totally fair. And that's kind of where I think a lot of people just kind of get it wrong with AOI. And that's why I'm kind of here today, is to discuss the approach I've learned, through my experience going to customers, supporting both AOI and SPI, and then coming to these conclusions that, to me, really change the landscape of how we can use this data. And the goal here for me today is to show you guys that data, show you how I've learned to process engineer around that data. Because I think if more folks in the industry can really start to understand the value of the data they're generating, not 6 months after installation, but on day one, and then actually being able to get that value out on day one versus spending 6 months validating to just maybe put it in line, there's a very big change in the value proposition offered. So that's really...
It sounds like you're saying that you're not just trying to help guarantee that a mistake never makes it out the door because your machine will catch that it happened and all that, but you want to make sure that people understand how to properly process and analyze the data and how to import that into their processes to then prevent future defects from even happening. And so
Correct.
you're not just reducing false calls. You're going to be reducing all calls because the boards are just going to get better and better over time before they're even at the AOI, right?
That's what we're driving for, and that's what the goal here is to establish that utilizing this data, we can create, a perfect template of what we need for each product. And every customer, every manufacturer has a different mix, a different volume. They do more prototyping, they do less prototyping, so it's so different for every single person. But yeah, that's exactly what we're pushing for, is the ability to drive what we call Japanese quality. And I want to highlight this a little bit. So if you folks have never worked for a Japanese company, there's a term called Kaizen. Kaizen translates pretty directly to the concept of continuous improvement.
Sure.
And when it comes to Japanese quality control, it's really never done. You're never done optimizing because you're always finding things that can be improved. And so what I've learned over the 6 years of my time at Omron is that if you can really apply that, you can do huge things with it. So I want to know up front, do you guys have questions, thoughts, things you want to add here?
Well, it seems to me what I'm hearing is that maybe the kind of MO of folks who are operating SPI and or AOI is to use them as kind of safety nets from allowing defects to enter the field. But what you're proposing is rather these are tools to inform your process and to make necessary adjustments to your process that prevent defects from ever occurring in the first place.
Correct.
And another thing is, you'll probably get to this. I'm just kind of curious when you talk about variance, and can you drill down to the impact that a different type of surface finish has on the same type of components and the different sizes and the different size of aperture that works on different types of components and all these types of things? Does it get down to what type of substrate it is? Can you really get to that granular level?
So what I'll say high level is we're going to see, because I myself have not dug into this data, and we're all going to dig into it together. That's awesome. Kind of the fun of this today, is that I don't actually know what I'm about to see, and we're going to kind of figure it out together because the data should paint some pretty clear pictures. That said, in preparation for today, I took the initiative to create a couple of samples. This is a project I've been working on for quite some time. I made a couple of samples using some training boards where we took an unoptimized stencil, then an optimized stencil, and made a couple of prints. Then using these couple of prints, I actually put them into my machine so that I could generate a significant chunk of data, just around 2 prints, one being optimized, one not being optimized. And, I think Daniel will find a lot of things very interesting. I think there's going to be more questions than answers from today, but that's the whole goal here, is let's figure out where we want to be talking about this, where the value is. Because I think, to your point, could you figure out how to drill down to all of that? Probably. But the goal here is to sort of share this with you guys so you can see the same thing. You can learn the same way I do. You can learn this approach, because it's really the approach I'm trying to teach here. It's really understanding this variance and how do we reduce it. Because if we can approach AOI and SPI with the concept of variance reduction versus eliminating false calls, it just paints a very, very different value proposition.
Sure, because before you can identify the sources of variance, you need to be aware that the variance exists. And then you can start to look at all these parameters and variables that could affect the final quality. But you need to know it's there and understand that it really is there. It's not just a blip that came up that you clear past, right?
Bingo. And that's the key of these machines that I'm going to be showing you guys today. And we're going to be focused today specifically on SPI data. Maybe sometime in the future we can do the same deep dive into AOI data. I just don't have the same quality AOI data today. But I'm excited to show you guys what I get to see, what I get to do on a regular basis, and kind of where I'm at in terms of my knowledge set, and see if we can all learn stuff together. So I think the best thing we can do is just really dive into it. So one of the first things I want to talk about before we really dive into this data is that concept of variance versus false calls. I know this is something that, I struggle with personally. I still find myself saying, hey, let's get rid of this false call. And I'm thinking, wait a second, is this variance of value? So what I've found over time,
Jeremy, real quick, what are we looking at right now? Can you kind of explain that? Because there's some people who can't see the screen. They might be listening to audio only.
Got it.
Good call.
So what we're looking at right now is a little preview on the data, and I'm actually going to take a step back here to get back to the main screen, and yes, it stayed loaded. So when it comes to SPI data, we load all of our data into what we call our data station, and the data station contains all of the historical data that we have captured from running production. And so in this case, being in our office, this is mostly just, test data from our testing. Doesn't contain images right now due to the size of the images. I might be able to get some images also later on. But that said, we're going to be really diving into looking at the data and the trends from both an unoptimized and an optimized perspective. Okay?
Now, when you say optimized, are you referring to the stencil?
I am referring to the stencil, and we'll get into that a little bit more later, but we're going to see that pretty quickly here. Go ahead.
Real quick question on that. And this might be jumping ahead, but
sure.
So when you optimize the stencil, are you then reloading a new paste file into the program, or are you continuing with the Gerber original data?
So you're actually asking a really good question.
That was a great question.
Requires a little bit of discussion here because, yes, the answer is yes, but I'm glad you asked that question. Here's why. So as I'm doing this myself, I'm thinking to myself, okay, I have Gerber that's been optimized from the stencil manufacturer, and I have the one-to-one Gerber. Now, I originally created the program using the one-to-one Gerber. And then, truth be told, what we're looking at right now is looking at the optimized data using the one-to-one Gerber file. Now, the reason I wanted to start here is because I actually believe we don't need to recreate the program when we've optimized it. The reason being, we're simply trying to make sure that whatever our original thickness was, we're just achieving what we wanted. So, if we're putting way too little paste down, we should probably know that if our original goal was to build at 5 mil, for example. So all of this, and I love that you asked the question once again, all of this is based in a 5 mil stencil thickness. I will say the optimized stencil is not 5 mils. However, I still ran it using the 5 mils. Now, the cool thing here is we may be able to tweak some of this data as we change, for example, the stencil thickness. But at this time, based on where I'm at in learning, I don't think there's a need to constantly revise the program itself because it knows what it should have been. And if we're revising around it, we should be using the same core data to revise it with. But that said, I want to open that question up to everybody else, anyone else that has experience with SPI. What do you guys think? Do you think we need to create a more optimized program to more specifically look at our reductions, for example, or can we look at the full original one-to-one and make our judgments using whatever is optimized to the original one-to-one?
I think from a stencil design standpoint, you're using the Gerber file that you upload into your SPI as a benchmark against the actual results. So as the stencil's optimized, the nominal values have effectively changed. So to compare an optimized stencil against unoptimized Gerber is comparing apples to oranges, right? Because in an ideal world, you achieve the exact results, 100% transfer efficiency on every location. And the thickness of the stencil and the XY dimensions of the aperture are going to be what you're benchmarking the results off of. So in my opinion, if you're inspecting the solder paste deposit, it needs to be against the actual Gerber that was used to create the stencil.
Would it not be showing insufficient if the optimized stencil is now a thinner, less mils of thickness? I mean, won't it be showing insufficient if it's measured against the original file?
Height and volume, right? Because if SPI is expecting 120 microns of thickness and the actual stencil's 100, you're automatically right. Even at 100% transfer efficiency, you're not going to achieve
then you
nominal
also have
results.
You also have shape as well. If you did a home plate and it was originally a square pad, then
that's a great
these are
great
all
point
factors
as well
that I wanted to dive into with you guys once again, because I figured to generate some data today, let's just run it all using the original one-to-one Gerber. And then once again, if we all agree that, hey, we should run the same test using the optimized Gerber, we can do that and we can compare those results. That's the great thing about this data. Sweet. Is it can just generate workflows almost infinitely where we can learn more and more and more. But with that said, go ahead.
I'll say this in closing. Not to close the entire episode, but even if there was a mismatch between the expected results and the Gerber file that was used to create the stencil, the optimized Gerber, you're still maintaining the ability to measure deviance within those results, right? So you could still see a tight pattern of variation from a stencil, even compared against data that isn't necessarily a match.
Correct. And that's, I think, what we're going to find here. And that's what I'm hoping you guys will be able to draw that conclusion by the end of kind of this dive in. So, if there are no further questions, and are there any other questions you guys want to, or any other inputs?
I'm excited to see this play out.
I'll keep talking the whole night if you let me, so go ahead.
Well, I might have to. So as we dive into this, the first thing we're taking a look at, this is the real data menu. On the right side, we have a series of buttons we can click on that allow us to visualize a little bit more about the data, but I want to paint a little picture of how we did this test. So there's 3 different data sets we're going to be looking at today. The first data set is me alternating between the unoptimized and then optimized board, which I want to highlight here. If we can see on the screen, we have some red flashing areas. The red flashing areas on the board itself indicate that is the unoptimized version. If I go to board number 2 here, you'll notice a lot of those red areas disappear. There are still a few there, but I will own there's some human error. I may have scraped some paste off the bottom right side. I did the best I could to not influence it, but I had to drive it home about a 4-hour drive. So it got a tiny bit damaged, which we're going to see in the data. I'll own that. But once again, board 1, this is unoptimized. We can see very clearly there's areas of red. Board 2, this is optimized. So the first preview of kind of what we're seeing is there is a difference.
Jeremy, real quick, when you say optimized, what was changed from Stencil 1 versus Stencil 2?
So Stencil 1 was a 1-to-1 match for the Gerber that was provided, being the training board we're using. So we just had full apertures cut to the exact size
no reduction, no shapes.
No reduction whatsoever.
Squares and rectangles, baby. I love it.
And then we went through and did an analysis on pretty much everything here and involved some experts that could help sort of provide some input on how we could best optimize this. And so the optimized version, I actually don't know every optimization that took place, but high level, we went from 5 mils to 4 mils for the entire stencil. Then you'll notice in the bottom right corner, we have some very, very small pads. Those are actually 01, 005 pads that we were having a lot of transfer problems with the 5 mil stencil that we very quickly learned were because of how thick the stencil was. So in that bottom right corner on the optimized stencil, we have a step down to 3 mils.
You did a step to 3? Okay.
Once again, high level, 6 boards we ran through. In reality, 2 boards just alternating unoptimized and optimized, unoptimized, optimized. This is data set 1. Data set 2, I'm going to show you guys quickly. That's from today. Data set 2 is now me running the same board 100 times over because I really wanted to be able to visualize that data and the repeatability of that data. So you can see on the left side as I scroll down here, I have 94 boards that were run when in reality I just ran this board 94 times. More to show the data so we can actually analyze the variance between the two and draw some conclusions together. The last data set is the exact same thing, but now with the optimized version. So once again, I have not done a deep dive into this data. I don't know what to expect here, but the nature of the beast with SPI and AOI is we don't always know what to expect. And so we need to go in with an open mind. We need to think about it like process engineers, see how we can actually address things to eliminate the root cause of the problem. So any questions before we dive deeper?
No.
Cool. All right, so I'm going back into the one that was just me running it, alternating 6 times over, so we can just go through kind of what SPI provides in terms of data. So distribution display is the next button down on the right side. This is where, for the first time, we can start to visualize some of our criteria, and I want to highlight what these criteria look like. So we have this drop-down menu in the upper right corner that shows us volume, height, area, high slice, middle slice, Shift X, Shift Y, and no solder. So as we're analyzing solder paste, these are the criteria we are trying to control to ensure that we provide a good quality print. And this also leads me to that Japanese standard I was mentioning. When you purchase an SPI machine from Omron, you get what we call DSpec, or the default specification. That default specification has been sort of pre-tuned to the quality control standard known in Japan to be sort of the best type of quality. Now, you guys probably are somewhat familiar with IPC 7525. Elias, you probably know a little more than I do about it, given I think I learned it from you.
That's a stencil guideline, right? It's not even necessarily a standard. Yes. It's a guideline.
Wow.
Bingo. So
shots fired.
We have a guideline from IPC on how to do stencils, but
the words matter.
Those guidelines don't necessarily break these things down, correct?
Right.
Yeah, there's no standard for volume mentioned anywhere in 7525, right?
Sure. So this is where we have to sort of make some decisions here. Now, the first thing I want to do is just take a look at the volume data in the upper right corner here. And what we can see is a series of different bell curves. And the idea as we're starting to do data analysis is we want to check for the repeatability and the sigma of any bell curve. And what I can see right away is I think I see 4 different bell curves. We have our bell curve from 75 to 100 that is by far the highest. And that's indicating, for the most part, everything transferred at about 75 to 100% of what we were looking for. 100% is perfect transfer. But then we have a bell curve that goes from about 100 to 125, indicating we have another little area where actually we're now getting a little bit too much paste. And it kind of tapers off towards that 150 end. But then we can also see on the very left side in the pink region, we have 2 bell curves that are trending in the wrong direction. And this is because this is where we had really, really poor transfer efficiency. This is a micro BGA that we're going to be able to see a little bit better. I don't know the exact dimensions of each bulb, but they are very, very, very small. And what we found using our 5mm stencils, we were able to get a little bit of paste onto it. But as you can see, when the trend is at like 1 or 2 or 3%, we're not getting a whole lot of paste there. So we can also see a color map in the middle. And the color map in the middle starts to paint the picture of the volume of where the problems are existing. And what we can start to see is there's a little bit of a gradient to yellow. As you notice on the right side, it gradients to yellow. In the middle, it gradients to yellow. That just indicates we're getting a little bit more paste in those regions. But going a little bit over 100% isn't really a problem. In fact, going over 125% doesn't necessarily indicate a problem. It's when we start pushing 150, 175, 200% that we start running into problems. So this is sort of the first preview into how we read this data. But let's go down one level. Let's take a look at height.
Now this is 100% TE at 5mm thickness.
Correct.
Okay.
And this is using the 5mm 1-to-1 stencil.
Gotcha.
So this is just the original data.
When I got mine, the biggest thing was, we actually printed out a chart of how many mils we should put in for based on what stencil, because that kind of determined what this software then determines what 100 is, correct?
Correct. 100% is based on stencil thickness.
Gotcha.
So that should influence the board that was built at 4 mils. We should see that very clearly in the data as we switch over. But mind you, there are more optimizations that took place. And I forgot to mention also, we used different paste. Using the 1-to-1, it was just standard AIM paste, I believe. And using the optimized, we used T4 paste.
Now,
that is another variable.
Were these nano-coated at all?
The 1-to-1 was not nano-coded. The optimized was nano-coded.
Okay.
So yes, that is one of the optimizations that took place, which hopefully we'll be able to see in the data as well.
Side
But
note,
because you, go ahead.
I ran some 01005s. Running type 4 pace wasn't that great, but running type 5 greatly improved my printability. I'd be curious if you when you get back to your lab to try some type 5 if you can.
Noted, and I appreciate that feedback. I think I'm more learning this sort of fresh myself, trying to become more and more an expert, on what would work best in T4. Like I said, we'll see the data here. It's not perfect, but it's better than the first one. So what we do notice on volume here is we got almost no transfer for the 0 and 005s in the bottom right corner. And in the upper left and upper right corners, we also had almost no transfer. But I want to highlight very quickly, once again, we're going to go to board ID 2, now acknowledging that this is the optimized version. And we're going to take a look at that data. Now notice, it is nowhere near the same as the first one. We're going to just flicker between board 1 and board 2 quickly. So board 1, we have a large amount of data trending in the wrong direction. Board 2, we have a little bit of data trending in the low area, but the vast majority of everything we're seeing right now is actually really close to 100%. Now, what's interesting to me, and I just want to throw this out there, is this is once again using a 4 mil stencil thickness. So what that indicates to me is that we're getting a little bit of a gap between the actual stencil and the board. And as we know, as we push down with our stencil and we use more or less pressure, we may have a little bit of a gap appear, causing it to have more than 100%. In fact, my experience has shown that generally most customers average 125 to 150% of their goal, which is a very interesting thing for me because it says to me that most customers use 50% more paste than they need to. You know what I mean?
Mm-hmm.
Yeah. So if I can jump in here real quick.
Yeah.
What we've been looking at so far, and particularly with the first set of data, is we're seeing the locations that have a lower area ratio where we're watching the transfer efficiency trend down with that area ratio. And that's expected, right? So in the optimized stencil, there seems to be more of a focus on accomplishing ideal area ratios on a local basis, be that through aperture design or reduction in thickness through a step. And that's maintaining a higher level of transfer efficiency. And in terms of the, I guess, excess and expected print height, I think there's several variables that could influence that, whether they're solder mass defined or copper defined pads, if there's silk screen involved in the assembly of the board, that can hold the stencil up off contact in certain areas. And then obviously release can influence that as well. Imagine the paste kind of dragging out of the apertures rather than cleanly releasing. Those are all potential causes or explanations for that excess and expected thickness there. Also coatings. Coatings can be an influence there as well. Some of these coatings have thickness involved with them, and they effectively increase the thickness of the stencil. So you could see a higher paste value in terms of height than you'd expect.
Sure.
I got a question if I could jump in real quick. Elias, is there, like on to prevent tombstoning, you might do a pad a certain way for a certain resistor size, right?
Mm-hmm.
Is there something that you would do? Yeah. And is there something that you would do for a BGA as far as shape-wise or anything like that?
Squircle.
Yeah, squircle is the way to go. So most of the time when you look at a paste file for a BGA, it's going to have rounds, right? They're going to be circles 99% of the time. And that's not actually the best shape for print quality. So, and then some folks will change them to squares, but now you got hard 90s at each corner. Your jet printer loves circles. Don't start with that. I've seen those pictures. Nobody likes them. So
the impressionists would agree.
A square has hard 90s, right? So that's a paste trap. Like, good luck getting a solder ball through an absolute 90. So that squircle, which is a combination of a square and a circle, or a rounded rectangle is another way to say it. That's the optimum shape for a BGA.
So like an octagon shape, or?
Nope.
No.
A square with rounded corners. Think of it that way. So you got a square, but the corners are radiused.
And the rounded corners are typically like a slide over print over the round pad, yeah?
Mm-hmm. Yep. You generally want to avoid angles in aperture design, right? Because that's not conducive to good paste release. You want smooth radius corners.
So like
sharp
an arch?
angles catch and trap, right?
I'm trying to picture this like an arch then on the corners.
Yeah,
sure.
Radius.
Sorry for asking.
You don't have to apologize. I just don't know what you're talking about.
You know how if you're turning in an intersection, you don't drive straight to the middle and then just make a hard left. You actually make a nice round turn as you go. Kind of like that.
See the corners on that?
There you go. There's a squircle. Okay.
Look at your phone. Look at your phone, Sean.
Your phone's
Look at the corners.
Yep.
In what text?
No, look at your actual handset. This is so good.
My handset?
The actual physical phone. Look at the corners
The phone
of it.
itself, bud.
Oh.
Yes.
Oh, all right. Okay. I'm like looking for the text. I'm like,
Oh,
what text I got
man.
from Paul?
It's too good.
Do not cut this.
You guys-
Do not cut this, Paul.
That's basically an arch. Okay, I was right. Okay.
Yeah.
Yes, yeah.
Bottom line is
McDonald's
he's going to say
aperture
he was
design.
right no matter what.
The Romans
Golden
invented the
arches.
arch.
Let's get back to progress.
Yeah.
Yes, let's get back to progress a little bit. So, back to data. I know it's super intriguing, and we're going to go through as much of as I can, make it as entertaining as it possibly can. And I just switched over quickly to my other runs, just so we can kind of look at the trends and understand. Now, this is back to where we can see the blue in the corners. That's the unoptimized stencil where we had our transfer efficiency issues. I wanted to jump into height just to kind of highlight here. Same thing. You know, when we don't have enough volume, we should see the same sort of problem with height. We did get some transfer, and we can see that here. It's just very, very little. So as we keep going down the list, we start to see more of the same trends where a lot of the data at 1-to-1 works. You know, the bigger parts, we really have no problem at 1-to-1. But, you know, as we keep going down, we see things like high slice, middle slice, and I want to just highlight these very quickly. So what is high slice for us? High slice, we go to 150% of aperture. And then we look at 150% of aperture. How much paste is up there? How much TPing has occurred when we did our separation? When the snap-off occurred, how much did it pull upwards? And the ideal is we should see almost nothing at 150%, right?
If you've got nice flat bricks, right? The way you want it.
If you have nice flat bricks, exactly. But what I've found over time, and one of the biggest pain points for all of my customers, is actually high slice. You might wonder, well, that's kind of strange. Why?
Is that?
Well, I also notice. Go ahead.
One thing that I would think might affect that is if you are pulling the board away and allowing it to leave before the squeegees have lifted off the stencil. Like a lot of times I'll make sure the board stays at print height until the squeegees are off. Then the board releases, and that way you don't have kind of conflicting forces there.
Separation timing, basically.
Mm-hmm.
Well, what I find a lot of customers struggle with is when we're looking at the volume data again here. You know, they'll trend average 150, 160, 170, 180. They'll even push their limits up to 200 before it fails. And as they do that, we'll start to see that high slice begins to also start failing nonstop. And then I get the emails saying the system is false calling too much. And that's where I immediately say, let's dig into this, folks. Let's teach you what I'm teaching you guys right now, and that is what is causing this variance here. Now, the reality here, there is no variance. This is a really good quality print. You know, but once again, when I'm going to most customers and I'm seeing that they've overtuned volume and high slice to a point where it never calls anything out, it sends a whole bunch of alarm bells off in my mind, indicating to me that something went wrong in their process. And then all of a sudden, the SPI data started to false call. And so they had to tune the false call when the reality was something had fallen apart. And now
it was
they can't
indicative
detect
of
it.
something in their process, but they wanted to just keep going. So they just tuned it to where it doesn't show up as a problem on their machine anymore.
I'll be honest, I'm guilty of this, especially if it's like a quick runner and I don't have to run a whole bunch. I'm not really worried about too much, right? I am like at a certain point, like you're saying after 200, right? It'll flag, but if I'm getting something crazy, it's just, I don't want to deal with it on a short runner.
Sure. And that's where the whole idea here is to just figure out why it's happening.
Yeah.
If we have the data to indicate it. And this is the number one problem our customers are faced with, which is exactly what you just said, Sean. It's that we can't make it disappear. Go ahead.
If this works the way you want, Jeremy, then the idea is big runner, short runner, doesn't matter. You're going to have your processes dialed in to where you'll know what to do from the jump. Even if you're running 20 boards, you'll have it dialed in to where you shouldn't have to widen your tolerances to allow that stuff. You should still be looking at good boards.
Correct. And that's where, the most recent approach I've taken to SPI has been, let's treat everything like new product introduction. When we do an NPI, we don't know what to expect. We don't know what the data is going to look like. And therefore, if we can process engineer with that data during the first run, that's where we can make a rev on day one. And I have a few customers now that are revving using that data. And the quality differences between revs from AOI and SPI data are huge. And I'm starting to get some pictures of the solder joint changes that have taken place as the optimizations start to be implemented. Yeah. And this is where, the OEMs are typically most capable of taking advantage of this the fastest.
Yeah,
because, they're running the most products. But at the same time, this is of value to every single manufacturer. If this approach can be followed, like really generate as much data as you can up front, do what we're doing right now, get some heads together that are process engineers to really analyze it, and then figure out what we can do to fix it. You're looking at my first step of attempting that, and you're looking at the unoptimized version to start. But once again, we're digging into this because the idea is by the end of this experiment, we should see a perfect board that has almost no variance and doesn't call out at all at AOI, even when it's been freshly programmed into the system. That just indicates you've pretty much hit that Japanese tier of quality that's preset and you're pretty much there. That's where I want every company to be. You know what I mean?
Sounds impossible. Not going to lie.
Sounds awesome.
It sounds impossible for someone like Sean, and I acknowledge, but I want to hear it, please.
It just it just sounds impossible because, and you might be right, because part of my issue too is
this is what Orbach's trying to preach to you, though, Sean.
Yeah, but it for me to get this data, I have to put a barcode on them, right?
Yep.
And I only do that if the customer is paying for it. So
sure,
I don't have a laser engraver like some fancy people in Nebraska do. So I don't serialize or barcode even the rails unless the customer is going to pay for it.
So let me actually take something back that I just said. You said you have to have barcodes for this. And the answer is, well, if I want to be able to trace back a specific board barcode at a later date, yes. But the data we're looking at right now does not require a barcode.
Okay.
It just simply requires a place to put the data, and then it will auto-generate barcodes. In fact, where it says board ID 1, 2, 3, 4, 5, 6, 7, 8, 9, this is all the same board, remember.
So this is like the transition data then that you click yes on?
Yes, this is exactly the transition data.
All right.
So you're looking at the data set holistically rather than on a board-to-board basis, but it still can inform the decisions that you're making in your process. And I think what the beautiful thing is, and maybe something that as a CM you don't have the opportunity to do, but OEMs certainly do, is that you can take an initial run with an optimized stencil and harvest this data and use it to inform stencil design decisions on future revisions to really dial in your process.
Yeah.
But Orex talked about this before, and that's what my initial question earlier about, dialing in a specific component size and type and substrate and finish, all that kind of stuff, because that an 0603 resistor is going to be the same on different boards. A 0805 capacitor is going to be the same on different boards. I mean, you can get to the point where you know how to mix and match the things that work, even if it's the first time you're seeing a board, as long as you've seen those component types and variations before.
Sure. And that's where
I would
think
say
the whole concept...
yes and no to that. Because
where
that's assuming that it's assuming that all variables are equal, right? It's assuming that the board finish is the same. It's assuming that they're both copper defined or solder mask defined. It's assuming that their silkscreen conditions are the same, right? There's a lot of variables from assembly to assembly that even if it's the same component, even call it the same footprint on the PCB, there are variables there that can affect the end result.
Yeah, I think...
No comeback.
Hi, I'm Elias from Metal Edge Services. I don't know. I had to break the tension.
You're saying Hassel and Enig. You can't just you have to factor in all those type of things to get to a proper.
I have a quick question for Sean.
Yo.
And that is, I want to know how you approach NPI. So you're not building the same products, right? You're a CM.
Yeah.
So you get, you get an order, you get it all set up, and then you go to, run it. Talk to me about your process today.
Well, that's going to change because Elias takes all my customers and just tells them that they can do their own stuff. They don't need me anymore. But so what I'll do is...
Jordan Denko was smart.
There you go. Boom.
Got that.
It started with Jordan. So this is what I would do. Like, as far, you mean like SPI and AOI or just SPI?
Both.
Okay, so we will program the job on the speed print, our printer, and then obviously our pick and place machine. Then we'll load the Gerber file into the SPI. Then we'll bring it into the SPI. Then we do like the fiducial, where you like kind of program the color to it.
You said SPI twice. Were you saying AOI on the second one?
Nope. Still SPI.
Okay.
And then you run your first board through and kind of just make sure everything's good, that the fiducials are going to line up. And then once that's good to go, then I'm going to run that same board back through under auto inspection.
Okay.
And then obviously pick and place, reflow. Then I take which is hopefully a golden board, right? Because that's what I'm going to program my AOI to.
Right.
And then program that in there. But then we do that for the first 10 arrays.
Okay.
So we will literally check the first 10 arrays on AOI. And then from there, then we go upstairs and then go through all the different types of false calls, right? And kind of fine tune, is it a color thing or is it, is it skewing at all in certain components? The random false calls I get from that,
Sure. And so I just want to confirm, when you go to run a new job, how do you decide what settings for your printer you're going to use?
That for me is determined by the actual width of the squeegee blade I use. I use the default settings pretty much that were loaded into my printer from beginning. Got it.
And you very rarely will change those settings.
Very
correct?
rarely. The thing I'll change probably the most will be either the under stencil cleaning frequency, and then it'll also be sometimes the speed of the actual swipe across.
Got it. So here's where I want to sort of change your perspective a little bit on how you can utilize this data. And I don't disagree with any part of your process other than here's what I want to challenge you on. When it comes to your first print, you know what DSpec is. You've had DSpec. You have our machine. You've used this before. I want you to, if you haven't already, reset your DSpec back to factory settings.
Ooh.
And I want you to analyze the data with the real failures.
Ooh.
key.
I don't think they understand what. I don't think they really understand what you just asked me to do. Because all right, so basically, your machine comes with a like he's saying a very tight window almost, so you could say, right? And there's certain windows I've opened up so that way I don't have to hear beep beep and then click the images and see what's wrong and what's going on with this and that.
Right.
Can I just create a new one and then?
So in other words, you are the counter to everything he is suggesting.
Yes, which I think is good though, because
makes for great.
If I'm gonna learn something, right, I want it to be like, hey, I'll say it again, dude. Hey, you're an idiot. Do it this way, right? Like that's the best way. That's honestly, I go from being an idiot to now I know something, right? That's
to
great.
An idiot savant.
Yeah.
So here's what I want to sort of share with you, Sean, which I think can give you a little bit of perspective here.
Even keep the 5 mil on there when I'm running 4. Because 4 is my standard now.
I have. But I want to share this story with you, which is an experience with a customer I had.
Okay.
And that is, I went fairly early on in my SPI career to a local customer that had a lot of experience with SPI prior. And I walked in and, we didn't have any custom settings. We were just using everything factory default. And I said, all right, give me a print. And he handed me a print, the first print he made. And we went through these menus together, like we are right now. And I said, here's what the trends are showing. And he said, okay, give me 1 second. I said, okay. Comes back about 3 minutes later. He says, here's a new print. Try this one. I put it in. And I said, whoa, the data changed. What did you do? He said, I tinkered with a couple of the printer settings. And I was like, well, here's what the data shows now. It's gotten tighter, but we still have these opportunities. And he said, okay, give me 5 more minutes. Fast forward about an hour and 10 minutes, we had it truly passing D-spec.
Wow. It's impressive. I don't think people
realize Stencil, same pace.
Same Stencil, no optimizations.
Yeah.
Now, mind you, that was very early on for me because this gentleman I was working with also had a ton of experience with printers. So he knew how to tinker with every single setting. And I was learning from him at that time, being like, show me what options you're changing, because I don't know anything about printers. I just know the SPI data. And I walked out of that training being like, if every customer took this approach, where we just simply tried to do what we could to our printer to give us a passing print, there's a fundamental difference in quality from the first one you make. And that's really what I learned, and what I want to teach everybody at this point is that approach, because that's the approach that really allows you to unlock the value of everything you have. You know what I mean? And the concept of how viable that is in a contract manufacturing environment, which I will own, it's not always, but this is also not black and white in that, there are certain runners that may be more valuable to optimize around. Maybe the customer has had problems with a particular board that, they're having you do a prototype on to see if you can build a better quality version than one of your competitors. So there's all sorts of instances where you being able to process engineer with this data up front gives you a massive competitive advantage. And that's one of the reasons I want to push back a little bit, just to say, I totally get it. It's not something you can do with every product. But if you can do it with a couple of your products, just to validate the value you can generate with it, you may find some very interesting outcomes. Does that make sense?
It does. It kind of brings me to a point I want to make, and I'm going to play Sean's advocate. And Sean, if you don't agree with this, you can discount it as not your thoughts. But I think possibly a bit of what you were getting to, Sean, is that SPI is measuring the performance of your print within the process, whereas AOI is measuring final quality, right? That's the board's done, it's assembled, it's been reflowed. Final quality is being measured by AOI. So if some of these false calls, air quotes, don't lead to problems in AOI, then maybe the thought is, well, then they're no big deal. They're actually not of significance. Does that go a little bit into how you think, Sean? Like if at the end the quality meets all standards, you have, quote unquote passable boards by IPC standards, they're flying through the AOI with no issue. Are you not so concerned with some of these flags that come up during SPI, or am I completely off base?
2023, Sean would have agreed with you, but I'm 2025, Sean. And 2025, Sean, will tell you this. Because I always looked at it like station to station, right? Like the SPI, my goal was to be able to get this thing so that way it reflowed and looked good, right? But I never did the inspection myself, and I never did the rework myself unless it was something minor. But I don't have a KPI on how much rework has to be done on a particular job, right? So what if now 2025 Sean looks at like the whole picture, right? Like, so what if by changing a simple print parameter that allows me to achieve within DSpec allows me to get reduced amounts of false calls at AOI, right? So now I'm looking at this as, okay, well, now I can kind of learn what parameters need to change and kind of have that be my standard versus changing the DSpec, right? So instead of changing the SPI to be my world, change my printer to fit in the SPI range, because that's, it is kind of perfect that you're on, Jeremy, because I actually had a bunch of false calls on big aluminum can. And now that I think about it, the majority of it was like different skewing. You know how like just a minor movement, right? Like that'll pick up a false skew or not. And I'm almost wondering now, like maybe I had too much paste, right? Maybe okay, this, having this high volume might be okay for other components, but on this aluminum can, we don't want that to happen because it's and I do 8,400 of those boards, and those cans, there's 2 cans on every board, right? So that's 16,000. That's a lot of scanning and a lot of clicks through to say this isn't really a problem,
Yeah.
What if something like Jeremy's proposing, I can find that out earlier in the process, right? And just instead of like even having to get a new stencil made, I just change some setting in my print parameter. And then
I'm still trying to figure out why why it's a false call, and maybe Jeremy can help with this. If your AOI is inspecting to the standard that you wanted, and isn't it just a matter of whether there's enough percentage of it on the pad or not? And
Jeremy, can I answer this because I want to see if I'm getting it right? I just want to know if I know the software as well as I think I do.
Okay.
When you first originally design your board, there's a specific land for that component to be in, and anything outside of that land will flag, correct?
Generally, you're talking about for SPI, correct?
AOI.
Yeah, sure. We can say very high level, yes.
Okay. So if a component is outside of the box, right? So picture the leads of aluminum can, right? And the pads are always oversized in those guys, right?
Yeah, there's skinny leads every time.
Yeah, but they're not fitting like on a resistor, right? It's very large. And
it's like a quarter of the pad width or whatever.
Yeah, right? It's so big. So imagine you draw a box around one, right? And you're saying, listen, it's got to be in this box every single time. You may not notice it with your eye, but that AOI is going to pick up the slightest deviation from that.
But you're drawing a box that is tighter than the actual acceptable area?
I think, can I interrupt real quick? We may want to do some follow-up on AOI specifically.
Okay.
Because
I think
a whole other episode for sure.
There is a drive here to be able to tie this all together at AOI, that if I actually had the final board of this where I could show in AOI both the unoptimized and optimized, there wouldn't be a whole lot of questions here.
Can I try to answer real quick for Daniel?
Please.
I want you to correct me if I'm wrong too.
Sure.
The reason why you want your box there is to determine if your slope is correct when it's soldered, right? And various other IPC violations, right? So
when you talk about the box, I'm just trying to make sure we're understanding the same thing. So you draw a window around your land.
Yep.
And you're talking about the land window specifically?
Correct.
Okay. Yeah. So at the core, the system at AOI is looking using a series of different lighting types at the slope of that solder joint to determine whether or not you sufficiently wetted up and you have a good quality solder joint. And it can determine class 2 and class 3 metrics. So you can program it to either class 2 or class 3. So whatever IPC you're trying to hit, you can make it hit. But the whole concept here is by doing all of this stuff up front and by working on SPI, the idea is we eliminate all of that from happening in the first place. And the idea, in a perfect world, I'd have both, like I said, AOI and SPI data, but I can have AOI data at a future time where we can do this exact same thing where we dig in and actually see, the influence of too much paste and how it's actually causing problems or maybe not, for AOI. But the idea and what I'm trying to once again just reiterate to you guys is the more we can process engineer with both sets of data, SPI and AOI, and the more we can apply the concepts of what we're learning here to trying to minimize sigma, minimize the variance, we get to a point where almost everything you build, even when your variance starts to, stray a little bit, it's still near perfect. Versus, Sean, your experiences when you're starting to push that 150, 175, 200% paste, I've seen almost every customer in that similar situation be struggling quite a bit with tombstones. And I found a lot of links between too much paste and tombstoning. And that's where a lot of the feedback I've started giving is, why are you at 6 mils in your stencil right now? And most people, when you're looking at AOI data, you're not questioning your stencil thickness. But if all of a sudden everything you see is blue on your lands, everything is blue, that means your slope is always steep. You have no barrel pad at all. Yes, that's a good quality solder joint, but you're using probably 3 or 4 times the paste you need to create the same quality solder joint. So at a certain point, it's just simply saving paste, which is still a cost-cutting measure. It's not a huge one, but it's also how we can prevent the defects from occurring in the first place.
I say next Thursday we do the AOI one.
Yeah,
so go ahead.
I was going to say, I think we should kind of narrow our scope back to putting a nice bow on this SPI conversation, because AOI is just going to be another 90 minutes at least.
I 100% agree. And I think we can absolutely dive down the rabbit hole of AOI, and I love where we're going with this, and that we're trying to think about the link between the two.
Yeah, we can't stop thinking about the whole picture, but yeah,
sure.
For the purposes of a good episode, we do need to keep it tight to this focus for sure. Yeah.
So I do want to kind of quickly finish out the presentation on the SPI data just so that we're all on the same page. I think everybody is kind of starting to spin their heads around what can be done here, and that's great. That means you're starting to process what you're seeing a lot, but I really want to just show it all to you so you understand the breadth at which you have that access.
Jeremy, can I ask one question though? I'm just curious. Was anything changed on the print parameters from board 1 to board 2, or was just strictly stencil change thickness?
Stencil change thickness and paste type. That's the only two variables that changed.
Okay.
And
otherwise, it was the same printer. We literally did it side by side. We did this about 10 days ago or so. And I was able to snag these boards from a customer, but they were literally practical components boards. So we're in the process of ordering them right now, because this was my project teaching my customer how to do this with help of certain experts that will remain nameless for the moment. So that said, back to this, just to sort of finish things out, and we'll definitely get to more Q&A. We have volume, height, area, high slice, middle slice, shift X and shift Y. This is another thing I wanted to highlight quickly. With our SPI system, as you're probably aware, Sean, you can close the loop in feedback in terms of the shift. So if, you're noticing that in a certain squeegee direction, it's always shifting a little bit in the X or Y direction, our system can feed that data back in real time and then self-correct. So what we're seeing here is non-self-corrected feedback. This is simply just the data without any sort of feedback function built in, but it also shows me right away, Shift X, no problems. Shift Y, there's definite some problems. And we can see that a whole lot clearer here. So last one is no solder. I don't believe, we can see where we have almost no solder. And no solder is sort of the invert of volume here. So we can see where it's really becoming problematic. And when I did my first analysis on the first board and I sought feedback, the only thing I needed to understand here was, what can I do to improve my transfer efficiency on these 01, 005 pads and these really, really small BGAs? And the feedback I received was making a step. Now, that's the other thing I wanted to quickly mention here is vast majority of customers I've worked with don't understand what steps are in Stencils. And I find that fascinating because some of the companies I've worked with have been in operation for decades. And only one company I've worked with had one stencil with what looked like dozens of steps. That's how I learned about them the first time, was asking, what are these? And they said steps.
I've noticed it seems like a lot of facilities only have the knowledge that gets passed down from employee to employee as they go along, and very little outside experience or knowledge ever enters the facility.
Agreed.
It's very tribal.
Yeah.
Shameless plug. There's a fantastic YouTube and LinkedIn video about step stencils, created by some guy named Sean Kincaid with help from Metal Edge Services.
We can cut that. That's
nope.
fine.
Yeah, we'll cut that out later. So back to this.
I got editing rights, so I'll do whatever I
want. Statistical chart is going to plot that same data, but show me every single one. Now, this isn't super valuable because I use the same board over and over again. But if I could look at an entire production run and now actually gauge the variance over the entire run instead of board by board, this kind of indicates, and once again, here's all the sigmas, all the UCLs and LCLs, all the things that you were mentioning, Sean. It's all in the bottom right corner. So we have that control and understanding on how tight our process is right away. We have CP and CPK right here. So the idea is, the more data we have, you just need one really, really smart process engineer that can synthesize this data in 15 minutes and make all the changes. And that's really what I'm driving here, is the value of the process engineering that can be done in a short period of time with someone that has this experience. And that's the difficulty, is finding those folks, because they're not all over the place. You know what I mean? And I've had to learn all of this through those folks in the field that had that tribal knowledge to teach me what they had learned. And now I'm trying to teach it to everybody else and all your listeners right now, and how we can really approach this in an organically new value, when it comes to what we do and the work that we perform. So just to kind of finish this out, NG info is going to show me just a quick display, of all of the little areas we need to pay attention to. I can go in and I can go pad by pad and actually identify specific areas where things are worst. We can go down production process, and this is going to give me a series of charts, just high level, sort of how things are running. And then print trend is the last one, which is going to show us the ability to break down the data just a little bit further. So we still have these same options here, but now instead of showing me the average, maybe I want to start looking at the max, the min, the standard deviation. And the more data we have, the more power we have to make the decisions. But I want to go back to what you said, Sean, and that is, what if you were able to take all this data, synthesize it, make all those changes during that first NPI? How different do you think it would be today if that was your approach from day one?
It's weird because, and Tim Anderson's not going to like to hear this, but I was really had my heart dead set on buying the 2D pre-reflow AOI. But instead of spending that money on that, I'm actually spending money on my process, because we're going from just 9001 2015 to 1345 and AS 9100. And I got to certify all the employees, and I hired a process engineer So for me, like, it's a totally different mindset that I have now, where if you can dial this in, you're looking at the data. The machines are repeatable, they really are. They're reliable and repeatable. So if I can get my printer to be dialed in from day one, and like Daniel was saying earlier, once you start figuring out, some common threads, right? This board has this board has that. It'll make the process going further down the line even better. But like, when we took my Six Sigma class, I don't know if I mentioned that before, but if I'm having a problem at my AOI, what inputs prior to that cause that, right? And if I can change an input as simple as a print parameter, right? Some setting in the printer, that's amazing. That's like true ROI from your SPI right
Yes.
there.
Yes.
I mean, honestly, the ROI I've received just from right? Like insufficient solder paste, right? Like, and I had this Bluetooth chip, and I would get one out of every couple hundred would fail, right? And I had no clue why. Thankfully, we got our SPI, like, I don't know, maybe 500 boards in, and we started to realize that it was like bridging, right? And to the naked eye, you could never see that there's a solder paste going across it. So then all we had to do was increase the amount of underside stencil wipes, and like that problem went away. But like the ROI I got from that alone, because every board was warranted and it was $15 a piece, right? And
so that's something I've been kind of arguing and campaigning for here, is the idea of rework is expensive, right? Like rework machines are expensive. Having to do rework is expensive. The time it takes to, instead of things just flowing naturally through your floor, they get held up and stopped and pile up and have to get fixed. I mean, and that labor isn't cheap. So how much more beneficial is it to any CM or assembly line anywhere to recognize where the defects are happening and cut them out of the process at that level, so that you prevent the future reworks from ever being necessary? I mean, these machines surely pay for themselves if you are using the data that they provide to actually influence your process, right?
Yeah.
I will say this though, Jeremy, the term NG sends shivers through me and my SMT line operators. Like I see, like I'm okay with the Warren, right? The yellow, right? But
yeah,
that NG, she's got a nasty beep to her. You're like, oh no, what happened, right? Like,
right.
so you were just saying those words. It was like,
trust me,
trauma.
the first year of me doing SPI was waiting for the email saying, hey, it's beeping a lot and I don't know how to make it stop beeping. And my immediate response would be like, open your limit. It'll stop beeping. Because the human reaction is make it stop. Literally.
Yeah, widen the goalpost.
Yeah.
And it's also just natural to say, hey, I didn't like the experience I just had with that beeping machine, so I want to eliminate it from happening again. And this is really the crux of the problem.
Yeah.
And this is what I've found the human error takes over is, you get so used to just adjusting things a little bit wider, a little bit wider, a little bit wider. After a year, you've made a conveyor belt.
It's an expensive
because you've
conveyor.
only done the same thing over and over again. And you've now lost your ability to detect your defects.
There's no integrity to the inspection anyway.
Yeah, you've lost your ability to generate value because you're afraid of the beep. But that, I would say, is the core of most of the folks using AOI and SPI today, is they want to make it beep as little as possible.
I'm laughing because it's true, but like you can't say 100% though, right? Because like you still keep bridging and you still keep area on like really, really tight, right? So I want to make sure there's paste on the pads.
Right.
My big thing is volume, right? Like I'm okay if it's, or slope too sometimes, like I'm okay with a little bit of, if the top
Sure.
is a little bit
But
higher
that's
than the bottom.
indicative too. Like maybe it's been
100%.
stirred too much, or it's too warm in your facility, or too cold, or whatever has happening. But
like Orbach taught us, like if it's sloping, you might need to up your speed of your stroke, because then that'll
we
reduce.
should mention Orbach being Rev 2. We haven't actually brought him. So this is going to be the big reveal. We'll tell everyone what his LinkedIn hand. No, he would kill us. Can you imagine? I said that because for those 3 seconds that he was listening, I could already feel his blood pressure rising as he thought that was happening. But he or she, right?
Yeah.
No, Orbach is a hugely helpful figure, and for all of us, he just wants to stay anonymous. So anyway,
fair enough. The last thing I wanted to do is just quickly show you guys that same data with Optimized, and just show you how much tighter the actual sigma is. And we have all the data right in front of us here. So we can gauge instantly, whether or not the optimizations we made worked. And that's the key. If I have that instant feedback and I can read these numbers and understand what they mean, I can make those decisions in split seconds to fix a whole bunch of things that may now save the company tens of thousands of hours over the lifetime of that product. And that's really the value of process engineering here, especially when you have access to data like this. So that said, I don't have too much else. Like I said, I'd love to do a follow-up where we get to dive into some AOI of the same thing here and get to see sort of the influence between the two. I need some time to prep that data and get some boards ready for you guys. But I hope this has been
that.
I hope this has been informative, and I hope the audience also finds this informative.
I loved
it. I think they will.
I loved it.
Definitely. Jeremy, thank you so much. You've been really generous with your time. And also, we've all definitely enjoyed this conversation. It's been hugely helpful to all of us. Hopefully, our listeners and viewers have enjoyed it as well. I know we're going to be working on these things together. This isn't just a one-time conversation. Yeah. And hopefully, you'll be on again, like we said, to deal with the AOI. Before we go, you've mentioned it a few times, so we want to make sure to give you a chance to promote Omron and what they do, because we are very grateful. So go ahead, and if you'd like to bring up what you guys do better than anyone else at Omron.
Sure. So yeah, we are an automation company that's existed for a little over 90 years now. Our first product was an X-ray timer. We invented the AOI industry. We've been trailblazing both SPI and AOI for over 35 years, coming up on 40 years now. And we work really, really hard to ensure our customers' success. We are partnering with every single customer that, wants our hardware, and we want to see them succeed. So, what I'm showing you guys here, this is what I do with every single customer, and this is where we want to make sure that you choose Omron, you're going to get, the best service, the best quality, and, this machine will run forever. Not literally, but you know what I mean. So,
definitely. Sure. And when we got to, producer Paul and I got to visit you at the demo center that you guys have there. Man, that's something that anyone who's involved in process engineering or the selection of equipment, or is just interested in how SPI and AOI works in general, and automation and relays and all kinds of things there. Very enjoyable experience. So I think everyone should do that. So thank you again for being so generous, and hopefully all of our listeners enjoyed it. You can find us on YouTube and any of your streaming services, and all over LinkedIn. We mostly just follow Sean's coattails there anymore. It's disgusting. But so thanks again to everyone. Jeremy, this was great. Until the next time.
Absolutely. Thank you guys. Have a great rest of your evening.
You bet.
Thank you.